Paolo Caffoni is a PhD student, formerly at Karlsruhe University of Art and Design, but also I think one of our bridge experts between two research groups. This one, the AIMODELS research group in Foscari, and the AI Forensics research group in Karlsruhe. And is an old friend and collaborator. And I think what I could say about his biography is that Paolo is trying to merge in his research translation studies, semiotics, curatorial studies, and also he has been trying to study indeed the automation of language that happens through AI, through the lens of other disciplines, in particular, I would say, the tradition of translation studies. Paolo, should I say something else about
No, that's perfect. It's too much even. Great. So, good morning, everyone, and thank you for waiting and bearing with me. It was a very interesting morning already. I'm happy to be back at the University of Venice. Last year, I presented here a short paper on the question of classification and the concept of research in large language model and machine translation. Today's presentation will be primarily based on historical examples. In some ways, a continuation of that work, but with a forward-looking perspective. Before diving into the past, I would like to begin by introducing a contemporary problem in machine translation. I see that it's not going. I can scroll down if you want. Well, you tell me.
Faccio io, Cristiano, non ti preoccupare. Sorry. Visualizzo modalità schermo interno.
Ah, perfect. Let's see if it works. Yes. So, in November 2016, researchers at Google announced that their flagship product for automatic translation, Google Translate, have switched from phrase-based statistical machine translation to neural network technology. This might be well considered the beginning of the success story of multilingual language model based on neural machine translation, which is to say a model architecture which is not fine-tuned on a specific language pair, but that adapts constantly, modeling 100 plus, today 200 plus languages supported by the system. Since all parameters are implicitly shared by all language pairs, there is therefore a single encoder-decoder. The model is forced to generalize across language boundaries during training. An unexpected advantage of training a model on multiple language pairs is its ability to translate between language pairs it has never encountered during training, a phenomenon known as zero-shot translation. For example, if the model is trained to translate from Korean to Japanese and from Japanese to German, it can also generate translation from Korean to German via transfer learning without having seen any data for that specific language pair. Crucially, this happened without relying on Japanese for mediation, that is, without explicitly bridging the translation from Korean to Japanese first, and from there to German. Zero-shot translation is thus a form of implicit bridging between languages pairs, with no explicit parallel data and no further fine-tuning required. Furthermore, by examining the sequences of context vector generated during the translation of a single sentence, researchers analyze visual representation of clustering in vector space and pose the following question, I quote, "The success of the zero-shot translation raises another important question. Is the system learning a common representation in which sentences with the same meaning are represented in similar way, regardless of the language, namely an interlingua?" End of quote. What does it mean to collapse the vector space of different languages? The shared representation raises two questions for me. First, it challenged the presuming commensurability of mental spaces between natural languages. Second, it reopened the question of inferring the unknown through language. I asked myself, is the vector space a kind of contemporary tourist bubble? This unexpected effect appears to be made possible by the shared architecture that we already discussed also this morning, which enables the model to learn across all languages. In 2013, researchers introduced the popular word-to-vec technique and experimented with distributed representation of words in vector space. By performing simple algebraic operation on word vectors, they demonstrated what has since become a canonical example in semantic computation: comparison obtained by projecting vector representation from the source space to the target language space made it possible, I quote, to infer missing dictionary entries using distributed representation of words and phrases, I close. Once the vector space is projected into the target language space, the model can output the most similar vector as translation. The similarity between the geometric arrangement of words in the respective latent spaces led the researcher to conclude that it is possible to learn an accurate linear mapping via rotation and scaling from one language space to the other. Distributed word representation have a long history. I just mentioned 1954, Zelig-Ehret proposed a systematic disregard for classical definition of meaning altogether. In place of subjective judgment or dictionary definition of meaning, he advocated for statistical measurements of linguistic distribution, formulating what would come to be known as the distributional hypothesis. In the same year that his much debated and frequently quoted paper on distributional structure was published, Harris also raised the question of whether the difference between languages could in some way be measured. He went on to define, I quote, what is the minimum difference or maximum similarities between any two language systems, unquote. To approach this task, he described the number and content of the instruction required to translate one language into another. What Harris called transfer grammar is a comparison of the distributional structures of various languages, English and Korean, for example, with explicit aim at the time of aiding the emerging field of machine translation. Harris designed charts or matrices that map similarities and differences between phonemes and morphemes, with rows and columns dedicated either to language-specific morpheme classes and morphological structure, or intersection between morphemes of different languages. The charts were organized so that each cell at the row-column intersection illustrate the phonemic or morphemic differences between two languages. As Harris explained, this design, I quote, serves the purpose of transfer, since instruction required to generate one language from another can be read out of it. So this was a preamble, somehow as a known history, and I formulate over that two research questions. So I aim to challenge the view that identifies predictability as the latest stage of technological innovation, and in doing so, I believe, treats it as a value-neutral development stripped of any political connotation. With this contribution, I hope to show that the predictive turn in language should not be attributed to a singular historical moment or era, nor can it be placed at the tipping point of a linear media evolution timeline, such as the one that recently was proposed by Lev Manovich with the term predictive media. Instead, I propose the hypothesis that language turns toward prediction when confronted with high levels of abstraction across linguistic practices and therefore social relations. To explore this question, I will focus on a few canonical historical cases in which language tended toward prediction. Thus, my first still unresolved question is, what is the nature of these abstractions? The second research question is, what is the value of prediction in language? And I noticed that contemporary Foucauldian discussion have aimed or sought to frame prediction within the rationalities of governance. Amoore, for example, has coined the term zero-shot politics to describe machine learning approaches to sequences where, I quote, the capacity to predict the next thing, the next anything, becomes a broader logic of order in the world, unquote. One limitation of such interpretations, I believe, lies in their tendency to foreground institutional control while overlooking the infrastructural and material transformation underpinning these systems. I would like to argue that prediction can also be understood through an analysis of the social and productive forces connected to language and translation in particular. So, in relation to my first research question, what is the nature of this abstraction? I follow suggestions that have been put forward by Kare Spark-Jones, Jacqueline Léon, and Lydia H regarding a reassessment of the interlingua project in the 1950s and the 17th century pursuit of universal languages. Despite the undeniable differences in economic and social condition, as Léon has pointed out, as well as in methodological approaches to comparative knowledge, as Liu reminded us, in both contexts, the idea of language predictability emerged as a central concern among philosophers. Furthermore, by concluding with the title or the subtitle with the word return, I intend to signal a suspicion that today techniques in multilingual vector space may have more in common with the totalizing aspiration of early modern rationalist thought than we might initially assume. Here is a little bit quote also to the image of the symposium, in honor to the image of the symposium. On the title page of Joachim Becher, 1661, Character pro notitia linguarum universali, characters for universal language knowledge, sometimes also refer as the key to the compatibility of languages. That was the subtitles. Pseudo-ideograms, this is a definition by Umberto Eco, are clearly engraved on an obelisk. While a group of attendants, likely speakers of different mother tongues, is shown manual at hand, interpreting the signs for the purpose of conversation and translation. Becher newly designed characters were essentially a numerical notation system based on Latin, but have often been seen as a precursor to modern computer translation. Perhaps this impression was reinforced by the fact they appearances which resemble instruction for an electric circuits. What stands out to me, however, is the positioning of the character on the obelisk, serving as a mediating code between natural languages. In 17th and 18th century, it was not uncommon for European philosophers, Jesuits, and others to reference Egyptian hieroglyphs when discussing universal mathematical or philosophical language. At the time, it was widely believed that Chinese character and Egyptian hieroglyphs, unlike the Latin alphabet, did not represent speech sounds, but rather ideas, and thus were better suited as a model for a perfect language. Nevertheless, the Orientalist gaze of thinkers such as Kircher, Becher, and Leibniz projected these systems as a timeless and ahistorical. They show little interest in understanding such scripts as a product of evolving social relationships and culture. It was, however, not until Hegel that we assist to the idea and the return to the idea that truth resides in logos only, and then the alphabet was once again crowned king. This is another image that was used for the symposium. John Wilkes' essay toward a real character in the philosophical language from 1668 is often characterized by scholars as a proposal for a universal language. However, Wilkins' true pursuit was the development of a form of writing that would be the only way to unite the 72 languages of the first confusion, meaning the fall of Babel. His proposal was divided in two parts. First, the real character, consisting of special symbols assembled according to rules and legible by all nations in their own tongues. And the second, a philosophical language, intended as a substitute for existing languages, different from them in that it would be created in a single founding moment according to the rule of ours, rather than through a longer perilous process like English or Latin. Why devise real character if the phonetic alphabet of the philosophical language could serve both written and spoken communication? For Wilkins, real character, as much as numerals that conveys the same meaning to speakers of all languages, promise to make writing fully independent from speech, breaking the long-lasting Aristotelian tradition that regarded language primarily as a speech act. Descartes show a certain ambivalence in regards to the idea of universal symbolism in language. In a 1629 letters to his friend Marine Mersenne, Descartes notes that the Indo-Arabic numerals system can represent an infinite quantity of numbers using just 10 symbols, combined according to straightforward rules. He remarks that in a single day, one could learn to name every number in the infinite sequence, and in doing so, write an unlimited number of words in an unfamiliar language. I quote, "I think it is possible to invent such a language and to discover the science on which it depends. It would make peasants better judges of the truth about the world than philosophers are now." But the problem that Descartes noticed is another. In order not only to learn, but also to remember the primitive names, they would need to correspond to an order of ideas or thoughts that follow the same logic as the order of numbers. This problem coincides with that of true philosophy, capable of defining a system of clear and distinct ideas. This kind of mathematics of thought would allow us to articulate, just as we do with numbers, all the ideas we are capable of thinking, unlike the words of natural languages, which refer, according to Descartes, to confused ideas. Although Descartes entertained the idea of a universal symbolism, he was skeptical that the dream could be ever realized. From a Cartesian perspective, a science can only be expressed with the clarity of numerals when it rests on principles as certain as those of arithmetic. Until then, the universal character would have to wait. It is known that at the turn of 17th and 18th century, Leibniz's project for a philosophical language was largely unsuccessful and flooded with the universalistic mentality of the time. Leibniz himself, like Descartes, doubted the possibility of constructing the perfect language and believes that the real strength of the Characteristica Universalis lied in the advancing the art of combination. But while accepting Descartes' observation, he denies that the construction of universal characteristics need to wait for the completion of true philosophy, and the construction of the two endeavors should proceed in parallel instead. In this sense, Leibniz's project differs from the universal language as conceived by Becher, Wilkins, and others. Leibniz, who on several occasions had expressed his admiration for the plurality of natural languages, celebrated the very confusio linguarum that other authors have sought to erase. He was not interested in overcoming impairment to communication derived from the incommensurability of language at the benefit of colonial trade or academic exchange, as Dalgarno or Wilkins did. Rather, it was his ecumenical faith that led him to reflect on a scientific language that would also serve as a tool of discovering the truth. In this sense, his ideal of language is closer to Ramon Lull, 13th century ars, conceived as a system of general principle of combinatory logic aimed at providing truth about God and creation. But unlike Lull, Leibniz does not seek only to demonstrate statement associated with what he considered a logical truth. He's interested in an inventive logic in which combinatorics can generate previously unknown proposition through mathematical calculus. He called blind thought the ability to perform calculation by means of words, of other symbols, and arrive at exact result using symbols whose meaning is not necessarily known or cannot be grasped clearly and distinctively. Such a thought is blind because by employing words or any kind of symbol, we do not see our own thoughts, which remain concealed behind a curtain of material signs. The thought occurs by performing mental operation using signs without grasping the meaning they represent. The thought is blind because the use and exchange of signs takes the place of the conscious apprehension of ideas. It is by virtue of this ability, its ability to manipulate signs without evoking the corresponding concept, that blind thought, in its effort to augment the reach of our mind, does not impose an excessive strain. It's just like a telescope enhance our vision. In 1679 paper on the general characteristic, he described his project of universal language as, I quote, a new kind of instrument which will increase the power of mind much more than optical lenses strengthen the eyes, and which will be as far as superior to microscope or telescope as reason is superior to light. Unlike some of his contemporaries, Leibniz was conscious of the interconnection between human capacity to comprehend reality and the capabilities for language. Language, therefore, does not constitute an impediment to knowledge as a barrier between the mind and the world. On the contrary, under certain conditions, a learned skilled language, like the lens of an optician, is in the position to magnify or distort the human apprehension of the world. The magnified effect Leibniz hoped to and predicted for passes through a system of characters capable of such precise calculation that mental error would be equivalent to an error of computation. In this sense, logical reasoning would be reduced to mechanical procedure, relying solely on the substitution of formal characters. So I quote, the only way to rectify our reasonings is to make them as tangible as those of mathematicians, so that we can find our error at glance. And when there are dispute among persons, we can simply say, let us calculate without further ado so that we see who is right. With the famous, let us calculate, Leibniz wanted to automate the labor of the philosopher, or better, logical reasoning, I would say. He tells us that the idea of inferring the unknown, it is less about the ontology of the machine. Today we would speak of computer, neural networks, AI, but the problem of epistemology and language. The fact is that no peasant mastered the magnifying art of the characteristica universali, nor anyone else for what is given to know. At best, as Umberto Eco reminds us, it is the binary language of computer which realizes, at least in parts, Leibniz's dreams of combination possibilities. Today, Emily Bender and Timothy Grebu would have blamed Leibniz's blind thought of being just another stochastic parrots. Yet, it is indeed this capacity of inferring the unknown, both in terms of stochastic prediction, but also in terms of ungraspable meaning brought by science manipulation, which precisely interests Leibniz. True is that language model science manipulation, despite their exceptional capability in ars combinatoria, did not bring to the demonstration of any fundamental truth to humanity, as Leibniz would have hoped. Quite the opposite. Their generative potential seeks to complicate the act of discerning reality even further. In this sense, if the goal of Leibniz's blind thought was to be found in a deterministic discovery of truth, it sits in stark contrast with LLM probabilistic predictions. Now, in reference to my second question, what is the value of prediction in language? I would like to briefly revisit another history of early 20th century application of statistical method to language. The title, The Entropy of Language, is not entirely accurate, but I use it nevertheless tentatively to describe a shift of focus from reading that emphasize a more normative application of statistics to language to those that place greater emphasis on a praxis and a productive aspects of language. Already in the first decades of the 20th century, Russian symbolist man of letter Andrei Belai pen name of Boris Bugarev, understood the epistemological problems of looking at art object through scientific investigation. Questioning principle of aesthetic form common to various arts, Belay arrived to establish an interpretation of aesthetic which rose from the analogy of the laws of physics. The application of scientific principle in Belay prose and poetry has often been overlooked, yet as early as 1906, Belay sought an analogy between his core theory of conservation of creativity and the first laws of thermodynamics, namely the conservation of energy. He writes, "A poet using a smaller quantity of external effort, kinetic creative energy, in the creation of his artwork, will transfer his effort to charging the poetic image with internal creative energy. The total quantity of energy is always the same, this entailed by the principle of conservation of creative work." It is precisely the analogy of the parallel with physics and a comparison with the laws of thermodynamics that allows Belay to conceive language as a measurable entity. That's what I'm interested in. In this sense, versification constitutes a privileged field of experimentation. If creative effort can be measured in terms of energy output, the metric and the rhythm of versification lend itself to be an ideal candidate for the application of statistical method to language. In an essay on lyric poetry and experiment of 1909, Belay sets off to distinguish metric from rhythm. He writes, "Rhythm is the actual expression of natural melody of a poet's soul, the spirit of music. Matter is the precise, crystallized, artistic form of rhythmic expression." End of quote. This distinction opens the way to a bottom-up, I believe, a bottom-up approach to analysis of versification, where the focus is not the conformity to the canon, so not the conformity to metrics, but on the various instances in which the rule is broken. So, to analyze the relation between metric and rhythm, he first described a corpus of iambic tetrameters in Russian poetry, establishing the position in the verse of half accents, so deviation from the vocal accent of the iambic feet, which take the form of two unstressed syllables in the pyrrhic feet, and representing the result on a graph where to each half accent corresponds, so each time the rule is broken, corresponds a dot. In this way, Belay proposed to find rhythmic individuality of a poet within the boundaries of a given metric form. This relation between rhythm and meter is represented, visualized rhythm with the figures obtaining, connecting with a line the dots, and the meter of the standard iambic verse with the intervals between them. Belay remarks that if the geometric figures are the same for all poets, their combination sequence is peculiar to the individual rhythm. Secondly, comparing the frequency of half-accent characteristic for each poet, as occurred in 596 verse recorded, Belay creates statistical tables which he contextualized historically, showing the essence of rhythmic revolution in Russian poetry, according to his words. Belay will be among the first to recognize the importance of statistical analysis applied to language in the Russian context. His linguistic statistical method will exercise considerable influence on the establishment of an independent literary science by formalists of the Moscow linguistic cycle and the St. Petersburg Society for the Study of Poetic Language. Literature was then endowed with that principle of scientificity which had already been granted to language in the 19th century, precisely due to separation from the literary work. Thus, when Shklovsky declares his interest in the internal laws of literature and establishes the well-known analogy of the text as a machine, which also Matteo has quoted often, he defined literariness as the result of a sum of textual devices which perform against the automatism of poetic perception. Shklovsky's notorious concept of defamiliarization leads us, Ostrani, leads us towards a conception of art in which the difficulty and the duration of the impression of the object serves to destroy what he calls automatism of perception, a sort of algebraic method of thinking which Leibniz would have certainly endorsed, prolonging its process through semantic variation. Shklovsky rejects the principle of artistic economy and opposes it with the device of defamiliarization and the notion of impeded, distorted speech as means of destroying automatism of perception. The purpose of art, then, is to lead us to a knowledge of a thing through the organ of sight instead of recognition, by defamiliarizing object and complicating form. The device of art makes the perception long and laborious. The perceptual process in art has proposed all its own and ought to be extended to the fullest. Shklovsky's concept of perception was in depth to Spencer's philosophy of style and his positive belief in art economizing mental energy, which will, in the 1940s, also have an influence of Zipf's laws for word probability distributions. Spencer advocated for a law governing the economy of creative effort, for which the reader or the hearer could apprehend with the least possible mental effort. This idea made its way into Russian context through the writing of Alexandr Vaselovsky, one of the few earlier critics the formalists did not entirely dismiss. Vaselovsky believed that poetry achieved its effects with a paucity of means impossible to prose. I quote, "The merit of style consists precisely in this, that it delivers the greatest number of ideas in the fewest number of words," end of quote. In particular, rhythm and rhyme contributed to the conservation of mental energy through their predictability, thereby avoiding what later Jacobson will term frustrated expectation in the reader. Shklovsky directly challenged this notion. While the idea of mental economy might hold for practical languages, art, he argued, resists such an efficiency through a process of defamiliarization which elevates perception to a state of maximal effort. Also, Yuri Tinyanov treated rhythmical segmentation as a quantity of labor or energy expended. Yet, contrary to Shklovsky, for whom the verbal art as energy-extensive language was to be measured primarily on the frustration of expectation produced in the perceiver, thus requiring more effort from its part, Tinyanov invokes the labor involved in the rhythmical organization of the verse. This labor of the addresser is the source of energy which is transferred to the rhythm. I quote, "Not the acoustic concept of time, but the motor forces concept of spent work should be placed at the center of the discussion on the question of rhythm," end of quote. Tinyanov criticized those theories which try to explain the verse and rhythm in terms of equal time intervals or isochromism, such as in the case of music. He argued, following Tomaszewski, that the meter deformed the sentence in order to redistribute energy of speech. I quote, "the role of meter as impeding speech," end of quote. Tomaszewski had recognized the value of Belai's early experiment, but criticized it for a sort of dilettantism and rush use of statistics, which could easily transform in mere accounting. Tomaszewski does not reverse the symbolism or Belai's dichotomy between meter and rhythm, upon which Belai had constructed his method, but reframes it within the study of actual possibility and concrete forms of the phenomenon which subject to this norm. In 1919, a lecture before the Moscow linguistic cycle, Tomaszewski affirmed the problem of rhythm cannot be considered in relation to an imaginary meter in isolation, which turns the rhythm in a mere statistical enumeration, but it needs to be considered in relation to, I quote, "the distribution of expiratory," so brief, "energy within a single wave, the line itself," end of quote. The idea of rhythm is therefore applied to elements of speech which play parts in the structure of the verse, in a set of tendency comply to one degree or another with this form. Thus, Tomaszewski's 1919 study of Pushkin, iambic pentameter, used Markov chains for the statistical investigation of verse and measure the tendencies of syllables to be stressed. I quote, this data, I quote from Jacobson, this data gave in the early 20th century a theory of verse based on calculus and its conditional probability and of the tension between anticipation and unexpectedness as the measurable rhythmical value and the computation of this tension, which we had labeled frustrated expectations. I am going to skip this because I think that everybody is familiar to Markov chains. And I'll just point out to the diagram that in Karlsruhe, David Link a few years ago made of the counting method of Markov, showing the first 200 sequences of letters and explaining how he arrived to his calculation of mathematical dispersion. Yeah, I wanted to. So, yeah. 30 years later, Markov presented his reading of Pushkin poem. 30 years later, information theory revives Klossky theory by explaining to us that information conveyed by a message decreases as its probability increases. Claude Shannon will work on what the formalist has despised, namely the automation of perception, described in terms of redundancy in language. In mathematical theory of communication, Shannon uses, again, Markov chain, not to analyze, but to generate text for the first time. He described the n-gram model, which, building on the Markov process, is able to predict the most probable letter of word to appear in a given n sequence. Shannon concludes that a mathematical model of symbols governed by a set of probabilities can satisfactorily represent language as a discrete series of symbols. But providing mathematically such consideration seems to him just a matter of stating the obvious. Indeed, Shannon believed that any speaker possesses an implicit statistical understanding of their language. I quote, familiarity with words, idioms, cliches, and grammars enable them to fill in missing or incorrect letters in proofreading or to complete an unfinished phrase in conversation. End of quote. Shannon provides the following experimental demonstration. A person is asked to predict the text on the first line, guessing one letter at a time. Each time the prediction is correct, a dash is recorded on the second line. When the prediction fails, the correct letter is shown to the second line, and the experiment progresses to the next letter. The results show that of 129 letters, 89 were guessed correctly, so that's 69%, and that the errors appear frequently where there are more possibility for branching, like at the beginning of words or syllables. Yet the challenge is to provide a measure for the uncertainty involved in the process. I quote, how much choice is involved in the selection of the event, or how uncertain we are of the outcome, end of quote, asked Shannon. In his quantification, the fundamental value to be measured is not semantics, as we know already, but what also Wiener in the same year had called a decision. So when Shannon repeats the experiment, we'll ask the subject to continue guessing the text, later till the correct selection is found. This time, the second line indicates the amount of guessing necessary at each step. And also, in this case, the reduced text contains the same amount of information of the original, but an n-gram predictor, that's how we call it, so the subject, has translated the English alphabet, 26 symbols plus 1 for the space, into a numerical sequence of 1 to 27, with number 1 showing the highest frequency. For Shannon, this numerical translation has made explicit unequal probabilities of the new symbols and their redundancy. Yet, predicting the upcoming letter of word in literary texts, such as poetry or the prose of James Joyce, involves conspicuously more information than the inference of vocabulary of basic English, which contains only 850 entries. Shannon notoriously would describe such information in terms of low and high entropy in communication channel, a quantification of uncertainty to calculate how much could be anticipated within a communication system. I have 5 minutes, so I don't have, I would say, I don't say that my research questions have been exhausted just with these historical examples. This is also a fragment of an ongoing work. So I wanted instead to try to create a directions and maybe possibly also close as far as we started this morning with the title, The Automation of Ideology, as a question mark, which, interesting enough, was also something mentioned yesterday. I was struck 2 years ago by a quote by Lev Weatherby, who said, GPT systems are an unprecedented view into linguistic makeup of ideology. There has never been before a system that allows us to generate and examine what is near what in political semantics. I was somehow suspicion of the novelty that Weatherby was ascribing to this process. At the time, I was also reading 2 books. One is Kingdom of Characters, and the other one was The Chinese Typewriter, where they were explicitly like kind of defining the history of how autocomplete or predictive text came about. So this novelty ascribed to GPT was for me suspicion at the time. But nevertheless, I decided to conclude with another notes on prediction that maybe can contribute also to the discussion. So it is known that Antonio Gramsci was not unfamiliar with the problem of universal languages. Indeed, he was studying linguistics at the University of Turin under Matteo Bartoli at the time where the mathematician and glottologist Giuseppe Peano, who gave us the modern axiomatic definition of the vector space, had published, inspired by Leibniz, Latino sine flexione, so Latin without inflection. Was his version of an interlingua for international scientific communication. I don't know if Matteo would call this sine flexione a form of dimensionality reduction. Gramsci rejected the ideas that theorize natural languages as the root of error and criticize artificial languages, the language of the bourgeoisie cosmopolis, he called them, constructed without any social or cultural participation. I quote, "The failure to comprehend the historicity of languages and hence of ideologies and scientific opinions has resulted in a tendency to construct an Esperanto of Volapük of philosophy and science," end of quote. Already in 1918, during a quarrel with his editors at the journal Avanti, and in polemics with the socialist promotion of Esperanto, Gramsci acknowledged that the impetus for a single language had appeared in various historical moments, such as the 17th century dogmatism and the 18th century Enlightenment, but characterized these attempts as expression of anxiety over the unity of bourgeois thought. I quote, "The advocates of a single language are worried by the fact that while the world contains a number of people who would like to communicate directly with one another, there is an endless number of different languages, which restricts the ability to communicate. This is a cosmopolitan, not an international anxiety, that of the bourgeois who travels for business or pleasure, of nomads more than of stable productive citizens," end of quote. What Gramsci negatively described as Esperantismo philosophical or philosophical Esperantism is indeed a positivism characteristic of both formal logic and universal languages. For Gramsci, I quote, "tendencies in linguistic change could anticipate movement not facts, which cannot be forecasted, but historical changes. He approached prediction from an operational and political perspective. I quote, "Prediction reveals itself thus not as a scientific act of knowledge, but as an abstract expression of the effort made, the practical way of creating a collective will." And I will end on this quote, which I think is large enough to close the morning. Thank you very much.
Thanks, Paolo, for this very deep, rich excursus. I open to the stage for questions. Okay, I see two here. Tobias first, and then Fabian. First here, the first row, to be fair with the order.
Thank you so much for that huge arc you spent. No, that's helpful. But I was sort of all the time waiting for something that you announced in the beginning, that is how this imports on like Louis Amoore and other sort of critiques of prediction as sort of mode of governance, especially now since you ended on that citation here, which is of course not Foucault, but there are some similarities nevertheless. So maybe you could quickly hint at how you would point all of that, what you did, against these Foucauldian readings.
Thank you so much. I mean, first of all, I have to say that I don't have anything against Foucauldian readings in general. I've been used also in previous work that I did, the archaeology of knowledge, and especially like kind of history, life and labor was very, very helpful to me. But nevertheless, I think I felt that the perspective, let's say, on governmentality has certain limits, especially when we are talking about these linguistic machines, let's call them like that. No? So I start maybe from the premise that for me, automation of language in these cases is like kind of automation of a division of linguistic labor, right? And in that sense, there is a component to the praxis, the social relation, the division of labor that Amoore, by reading a top-down governmental approach to what LLM are, it's not fully able to highlight, I think, right? So more than a critique with that, I think they could be two complementary perspectives, right? That is my short version to the answer.
Fabian?
Thank you so much. That was fantastic. And I want to ask you about the relationship of the earlier part of your historical reconstruction to your actual object. So I want to ask you about universal languages, about Leibniz and Wilkins and so on, because what you're presenting here is, of course, a kind of like default genealogy, right? This is where people start. But I want to push back a little bit on this and hear your thoughts about the actual connection between these things, because what these are theories about reasoning, right? They're not about language, really. Like Leibniz really imagines two dudes in a bar fighting, and it's like, if we only, had numbers, to be more precise, then we wouldn't have to fight. That's kind of like the idea here. So I'm wondering about your take on the kind of like default timeline, right, which starts at Leibniz, at Descartes, at Wilkins, and so on. And there's that detour, of course, through Borges to Foucault. Like it's kind of like always there as the kind of like starting point. And at the end point, we get artificial intelligence systems. So I'd love to hear you talk a little bit more about that. Related to that is the second half question, which is, I would also love to hear you talk more about the role of computation, which didn't feature at all here, right? So what does it mean that we use computers for all of this at the end of the day? Turing was absent from the list of kind of like prominent people here. And I'm asking that not to prove as a provocation, but really to tap into your historical expertise on these things. I'm curious to hear more.
There are two very good questions, and I can collapse it also in one short or maybe not too articulate answer. So for me, like kind of the history, it's a little bit part of like kind of my methodology to understand this object that we look at that today. Also, I propose a questions that every time is different. This time it could be like kind of, okay, what understanding emerge from this, what understanding of language, not of computation. What understanding of language, because I'm interested in a history of philosophy of language, not necessarily in a history of computation, right? So what understanding of language emerged by this problem of computing language in the vector space, right? And I think it's more like a sketch. So I did three works that, three papers that every time they start from a contemporary, I call it a contemporary problem. One was the question of low resource languages in high and low resource languages in LLMs and in multilingual models. And second one was about tokenizations. And now I thought I start with zero-shot translation. Every time I start from this contemporary problem and I try to create a genealogy, right? The genealogy that I wanted to trace is always biased, first of all. In this sense, like kind of I announce, okay, predictability will be my guided line in order to revisit a canonical history. The part of the work that I presented today, I used modern philosophy, as you say, like kind of they were talking about reasoning, but for me it was extremely interesting the fact that the tension or the confusion, separation or reappropriation that happened between language and thought, especially in Leibniz, when the idea of like kind of, calculating something did not correspond to a conscious apprehension of the problem. So for me, their language actually rises very prominently as a problem. And as I mentioned, I saw that, there was the stochastic parts problem that has been many times being referred to today is exactly a negative description of this combinatorial power that Leibniz was discussing, right? I don't know if this is a good answer for your question, but on the second one, the fact that I exclude Turing is probably because of time. This was not a timeline, we could get into that, but also because it was less interesting for me for a genealogy of problem in relation to language and not to thought, right? Yeah.
Mercedes, I think. Here.
Thank you. I find it really inspiring and look forward to what you're going to do with that. It also made me think a lot, to return a little bit to Fabian's question about the role of computation. I think you partly, that's why we get all excited about it, you sort of slide through something that has been in the room all day, and like, what is this abstraction that is being produced in the language and in the LLM? And I think all of us are trying to think about how to work with this and how to describe it. And I wonder if you also, or we all also need to think against finding an idea, what that could be, and ask ourselves, where do the abstractions of Gramsci, of the LLMs differ, and where they overlap, because they're not always the same. And that's sort of, I find it really inspiring, just as a comment, first of all, what are the token predictions abstractions from? Are they abstractions of language and the structure of language? Are they abstractions of images? Are they abstractions of social relations and the ideology, or of the human artifice, or of the world? And they are both different things. And then where do we put the failure of abstraction? Where do we put hallucinations? Where do we put the six-finger hand, and so on? And then more to you specifically, because you're interested in the history of philosophy of language, I was thinking, what's the difference? It returns a bit to the part, the argument I just make, between the universal language of Leibniz, of thought and idea, and Gramsci's collective intelligence. They're both ideas, but they seem to move in slightly different, they're pulled in slightly different directions. And I think it could be really fascinating if you map abstractions, so to speak, and how they are filled differently and addressed differently in different arguments.
Oh, this is a big question. Thank you so much. I don't think I'm going to be able to respond, but overall, but it's definitely interesting points and direction that they give me an input for continuing working. I go back first to, you were mentioning something about failure, which for me was very interesting. I think that this afternoon also my colleague Tommaso will talk about model collapse, and we had an exchange about thinking, okay, well, how do we understand model collapse? And I brought in the question of what does it mean language collapse, no? And then for example, I trying to understand like kind of how a certain derogatory idea of what global English is as the fall of the collapse of a standard has been used and discussed in literature. So this idea of like kind of failure applied to language for me is also a very productive part. Hallucination, I didn't talk about it today. I talked briefly another time. It was very interesting when you have, these huge multilingual models. They zero shot, and sometimes where they arrive to some hallucination. It was very interesting when I analyzed one model, I think it was Facebook, called No Language Left Behind, that wanted really to expand the range of languages. When they were hallucinated, very often they were arriving to biblical references. And this is because the data set that he's built on was the John Hopkins corpus, like kind of where bytext has to be found in probably the largest amount of languages. So that is used with training. So in this sense, I don't think that answers this question with like kind of the Leibnizian ecumenical idea of, I think it's for me a good sideline way to connect the different parts. In regards to abstraction in Leibniz and abstraction in Gramsci, I think they sit so far apart that I cannot connect it. They were, I think the different direction was especially political that they were taken. So.
Okay, I think last question before lunch break to Hannes. There is also another question. It's only who? Sorry, Michel. Didn't see Michel. Sorry. Okay, but let's collect two questions.
All right. Thank you for this. This was really super interesting, and I appreciate the material that you brought together. My question is about the relationship between prediction, which is your topic, as I understand it, and two other concepts that you hinted, namely abstraction on the one hand and effort/labor on the other. Effort or labor. So those seem to be kind of related somehow. And I want to ask you to develop this maybe a little more. So what is the relationship between the different types of effort that you describe in relation to prediction as it pertains to abstraction? And what I mean is effort is an operative category in Shklovsky, right? The Ostranienia is a way to make the kind of the de-automatize de-automatize perception by making it harder to perceive. You have the kind of idea of effort and labor in Gramsci, but also you hint at the labor theory at the beginning. And in epistemology, you have kind of the back and forth between a Leibnizian idea of blind thought on the one hand, and the constant reminder to undo this, and most famously in Husserl and the Crisis book, right, where the idea of technization is exactly that what Leibniz describes as blind thought that needs to be undone in order to come back to some kind of pure epistemological grasp on the world. So how do these things hang together, if they hang together, in relation to prediction? I know this is a very big question, but I think there is something there.
because it's one. I mean, the idea of prediction itself, it's a vague concept, because predicting can mean many different things. So I think this is the first bias or the first limitation of like kind of using it for a linear reading, as I wanted to do. No, just I hinted. Let's think about how deterministic Leibniz thought was unsuccessfully, like kind of, and how probabilistic, like kind of, LLM is. So it's already an heterogeneous field, so to say, right? I was interested to connect prediction. It was like maybe a reading not of the maximum effort, but on the contrary. So to read like kind of the reduction that happens, and it becomes explicit in Shannon, the reduction as a form of management, management of mental labor, which takes the form of a prediction, not the form of maximum effort. So we could say, but this is also very, very broad, we could say that prediction comes in when a process of linguistic of mental labor needs to be optimized for best organizational, or like kind of in relation to the division of work, right? I don't know if this is an answer to your question, but I just connect prediction with that form of reduction and not with the maximal effort. As you say, when Shklovsky was describing what for him was exactly a reversal, no? It was a principle of maximal like effort. And I mean, there were also the limits, like kind of this, art for art, or internalist, if we call it, like kind of also in relation to what Gianni Gastaldi said this morning, no? An internalist reading of what literature is what we have from the formalist perspective, right? So in this sense, for me, there are some epistemological parallels that I'm mapping out in order to sketch, and also in today's discussion, what is internal and what is external, right? I declare myself as an externalist, but indeed, using also formalist, I analyze a methodology which was actually arguing for an internalist description of language, right? So, yeah.
The last remark about Michel.
Yeah, very quick follow-up related to the last question. One of the funniest sort of facts of the GPT-style generative transformer kind of architectures are that the production of every token costs the same amount of energy, or involves the exact same amount of multiplication, barring probably some optimizations people have done here and there. And that's obviously anathema to someone like Herbert Spencer, who wants to believe that certain types of thinking cost more energy or are more laborious or whatever. And we can imagine why Herbert Spencer might think that sort of thing. But I'm curious if you came across anyone who believed that thinking or language or reasoning involved sort of a constant amount of energy.
I worked a little bit on the question of the cost of language, starting especially from problem of tokenizations, because the amount of energy is the same, but paradoxically, cost of language differs, because tokenizer operate differently on different scripts, right? So when you have an API and you pay per million tokens, of course, when you use English or more in general Latin alphabet, like kind of that the tokenization is optimized, while when you use another script, it exponentially goes up.